Good afternoon, children. Welcome back to our online class. I hope that you all are safe at home. Yes. Are you all happy, children? Yes. So, shall we start the class today? Yes. So, in science first, now we are learning the lesson acids, bases, and salts, is it? So, in that we have completed acids, bases, indicators. Is it? Yes. So, do you like this lesson to learn? Yes. So, one more topic we have in this lesson, that is salt. Okay. So that we are going to learn today. So, shall we start the class? Yes. Children, let's recall what we learned in the previous class. Okay. So already we have completed acid bases, and then the last class we have completed indicators. So what is called indicator? Indicator is substances that show a change in color when brought in contact with acids and bases. Substances that show a change in color when brought in contact with acids and bases, is it? Then we have learned about that indicators that is commonly used in laboratory is litmus. It is extracted from lichens, is it? Two forms we are getting, that strips of paper and in the form of solution. Litmus paper, that is in two color we are getting, that is red or blue, is it? Okay. Next we have learned about the other indicators, that is phenolphthalein, methyl orange. In acid it is colorless, and in base, that is about phenolphthalein, in acid it is colorless, base it is pink, is it? Then methyl orange, acid means red in color, base means we will get it is in yellow color, is it? So if there is no change in color while we are using these indicators, we can say that substances as neutral substances. What are the neutral substances? That is example water, sodium chloride, sugar, etc. Then we have learnt about universal indicator. So their pH ranges we have seen, is it? The solution, how much strength it have. For that pH range is 1 to 14, is it? pH 1 means it is strongly acidic, pH 14 means strongly basic, and pH 7 means it is neutral, is it? Then about universal indicator we have learned. What is called a universal indicator? It is a mixture of indicator so chosen that it gives a different color or different pH values. So, the indicator can be used as a liquid or can be soaked into paper. This paper is called pH paper. Then we have learnt about natural indicator. Indicators can be prepared very easily from brightly colored parts of such plants such as flowers, roots, stems and leaves. Is it? Okay. Next we have learnt about the other indicators, that is red cabbage juice will change to deep red with acids, to purple with the neutrals, and to green and yellow with bases. Onion juice also shows similar color changes, is it? Okay. So next I have given one of the activities, is it? I hope that you might have complete that. So have you seen the effect of a natural indicator by using turmeric powder? Yes. So next we are going to learn the new topic, okay? Okay. So next we are going to learn about salts. Salts, okay? Salts is a general term used for the substances that are formed when an acid and a base react with each other. This reaction is called a neutralization reaction. Salts is a general term used for the substances that are formed when an acid and a base react with each other. This reaction is called a neutralization reaction. So they will ask the question, what is called neutralization reaction? So you should write the reaction in which an acid reacts with a base to form salt is called a neutralization reaction. The reaction between vinegar and baking soda is a neutralization reaction. Vinegar, as we already know, contains an acid and baking soda contains a base. So when vinegar it is reacting with baking soda, salt is formed, water and carbon dioxide gas are also produced as the products in this reaction. Similarly, common salt, that is sodium chloride, that is formed by the reaction of this hydrochloric acid with the sodium hydroxide. So that's why the equation becomes hydrochloric acid plus sodium hydroxide. Hydrochloric acid means it is an acid, then sodium hydroxide it is a base, is it? That both when it is reacting, the product is sodium chloride, that is with water we are getting, is it? Sodium chloride, that is the salt, is it? So salts can be acidic, basic or neutral, is it? Next we are going to learn about insect sting. See, this will happen quite common in everyday life, is it? So when a bee stings, it injects an acidic liquid into the skin. The sting is neutralized by rubbing calamine lotion on the skin. The lotion contains zinc carbonate. Zinc carbonate, that is a base, is it? Okay. So when a bee stings, it injects an acidic liquid into the skin, is it? So how we will neutralize that? That means how we will balance that? By rubbing calamine lotion on the skin. This lotion contains a base, okay? So that is zinc carbonate. Have you all understand? Important question. Insect sting. When it is stinging, it is giving some acidic solution in your body. Okay. So to neutralize, we are taking base inside. That is calamine lotion. This calamine lotion contains zinc carbonate. Okay. Have you all understand? So it is neutralized. So this is the one of the example for neutralization reaction. Okay. Yes. Next about indigestion. First insect sting we have completed. Next indigestion. Okay. To digest food, the liquid in the stomach must be acidic. But too much acidity leads to indigestion. One takes antacids which usually contain baking soda or magnesium hydroxide to neutralize the excess acid. So, to digest the food already we have that hydrochloric acid in stomach, is it? So, too much of this acidity leads to indigestion. That's why we should use that magnesium hydroxide, okay, as base, is it? That is to neutralize that excess acid. Have you all understand? So, that's about indigestion. So, insect sting we have completed, indigestion completed. Next, about soil treatment. Okay. So, next one, soil treatment. Most plants grow best in neutral soil. So, neutral soil means both acid and base should be balanced. Okay. Nothing should be more. So, if the soil is too acidic or too alkaline, that is too basic, the plants do not grow properly or do not grow at all. Okay, as an healthy manner. So, if soil is too acidic, base such as quicklime. What is another name for quicklime? Calcium oxide. Then slaked lime, that is calcium hydroxide. Or chalk. Chalk means calcium carbonate. Can added. Okay. If the soil is too alkaline, sulfur can add. Okay. So sulfur we can add when there is too alkaline. Okay. So most plants grow best in neutral soil only. So we should neutralize if any content it is. Next about factory waste. Liquid waste from factories often contains acid. If it reaches a river, the acid will kill aquatic life, is it? So, it is prevented by neutralizing the waste by adding base. So, In factory waste acid is there, is it? So to neutralize we should add a base. So for example, slaked lime we can add. Okay, so if you add this base with that waste, so both acid and base neutralized, and after we can send it, and it will not kill the aquatic life. Okay, so liquid waste from factories often contains acid, and we should add the base to neutralize, such as slaked lime. Understand? So application of neutralization reaction we have completed. So first point, insect sting, indigestion, then soil treatment, and the fourth point is factory waste. So next we are going to learn about properties of salts. So characteristic properties of salts are, the first one is melting and boiling points, then second one is solubility in water, then third one is water of crystallization. So first we are going to learn melting and boiling points. Salts are mostly solids. Okay, they melt as well as boil at high temperatures. So salts mostly they are solids. They melt as well as boil at high temperatures. Okay, that's the first property for salt. Then second one is solubility in water. Salts are generally soluble in water. Example, sodium chloride, that is the table salt or common salt which is in our kitchen. Okay, then potassium sulfate, aluminum nitrate, ammonium carbonate, etc. are soluble salt. Soluble means it is dissolved in dissolve. Okay, so while silver chloride, lead chloride, copper carbonate, etc., they are insoluble, they will not soluble in water. Okay, then the third one is water of crystallization. Okay, water of crystallization. Okay, so generally salts are found as crystals with water molecules present in them. This water is called water of crystallization, and such salts are called hydrated salts. Example, copper sulfate crystal has 5 molecules of water for each copper sulfate molecule. This is written as CuSO4 5H2O. Okay, copper sulfate 5 molecule of water, so CuSO4 5H2O. Then this water of crystallization gives a crystal its shape. It also gives color to some crystals. Example, copper sulfate, you all know that is blue in color. This is blue vitriol due to its blue color. On heating, hydrated salts lose their water of crystallization, and as a result the crystals lose their shape, color, and change to a powdery substance. Okay, so on heating, hydrated salts lose their water of crystallization, and as a result the crystals lose their shape, their color, and change to a powdery substance. Okay, so the hydrated salts that have lost their water of crystallization are called anhydrous salts. Anhydrous salts. When hydrated copper sulfate is heated, it gives out water molecules to form white powdery anhydrous copper sulfate. On addition of water, the substance will convert back to a hydrated copper sulfate solution again. Okay, so first we have learned water of crystallization and hydrated salts, is it? Then the hydrated salts that have lost their water of crystallization are called anhydrous salts. Okay, then we are going to learn about uses of salts. Now we have completed properties of salt. Next we are going to learn about uses of salts. Okay, uses of salts. So first, name of the salt we'll learn, and its uses. Now we are going to learn. Okay, say calcium carbonate. So that we will see as marble, limestone, chalk. Okay, what's the chemical formula for calcium carbonate? CaCO3. So its uses in the sense, flooring in the form of marble make lime, that is calcium oxide, CaO. Okay, Then cement. For extraction of iron, there and all, we are using this calcium carbonate. Then sodium carbonate. Sodium carbonate, it is washing soda. In washing soda it is, okay. So what's the chemical formula? Na2CO3. So 10 molecules of water it is present, so 10H2O, okay. Then uses. In cleaning, that in detergents, for water softening, manufacture of glass, here and all they are using this sodium carbonate, okay. Then third one is sodium bicarbonate, that is baking soda, okay, it's baking soda. What's the chemical formula? NaHCO3. Sodium bi means H, then carbonate CO3, so NaHCO3. Uses in bakery and medicines, they are using this sodium bicarbonate, okay. Then silver nitrate. Silver nitrate chemical formula is, silver means Ag, nitrate NO3, so AgNO3. So where we are using this? In photography. For what purpose? To develop films, okay. There they are using silver nitrate. Then fifth one is ammonium nitrate. Ammonium NH4 nitrate NO3, so NH4NO3, okay. Then uses, where we are using this ammonium nitrate? Fertilizers and explosives. Fertilizers and explosives, okay. Then potash alum, Fitcari. So what's the chemical formula? K2SO4, Al2SO4 thrice, then 24 molecule of water H2O, 24H2O. For purification of water, they are using potash alum. Then sodium chloride, you all know sodium chloride, that is in our kitchen, is it? Common salt, NaCl. That is the chemical formula for sodium chloride. Where and all we are using seasoning for food, manufacture of chlorine and sodium carbonate. So where and all they are using this sodium chloride? Seasoning for food, manufacture of chlorine and sodium carbonate, okay. So these are the salt and its uses, okay. So learn this, okay. So today we have learnt about salts, is it? In salts, first we have learned neutralization reaction, is it? Salts is a general term used for the substance that are formed when an acid and a base react with each other. This reaction is called neutralization reaction. Next examples we have seen. Then neutralization reaction are quite common in our everyday life, is it? For that 4 we have learnt. Example, applications of neutralization reactions, 4 we have learned: insect sting, indigestion, soil treatment, factory waste. Next, properties of salts we have learned. In that, melting and boiling points, solubility in water, water of crystallization. Then uses of crystallization, uses of salts, okay. Use of salt, some salt, name of salt we have learned, then its uses also we have completed. So today you have to learn, or you want to read page number 75, 76, 77, okay. Salts, okay. Salts, about salts, application of neutralization reaction, very very important, that you have to read, okay. Read thoroughly, and you should understand that. With concentration you will read everything. Then properties of salt, 3 properties is there, you want to learn. Then uses of some salts, it is given in tabular column in page number 77, that also you want to learn, okay. Then question I'll give today, that also you want to complete, understand. Then question answer and all I will give later, you want to mark or write in your booklets. So read thoroughly the whole lesson. We have completed this lesson, okay. Children, be safe at home. Thank you children, thank you.